Thank you very much. It gives me great pleasure to introduce the next speaker. It's Amy Erickson, the president of Alstom USA. Alstom is an electric power and rail transportation company, global company. Amy's background is very interesting. She's a chemical engineer from Penn State with an MBA from Harvard, very nicely educated. And she has spent her time in the industry. She's been with DuPont, ExxonMobil, ABB, and now Alstom. She has responsibility for product development, business development. She has held many different positions. She's located in Washington, D.C. Part of her job is to keep the policymakers in check and work with them closely. And above all, she has 6 children, very admirable. Please give a round of applause for Amy Erickson.
Good morning, almost afternoon. Can everyone hear me okay? Okay, first of all, I do want to say congratulations to Habibi and PAS on 20 years. Well done. We've been at it for a little over 100 years, and I can tell you it does not get any easier. Basically, as you will see in this presentation, we are still trying to find ways to make our technologies more useful, which is how we managed to find our way to PAS. And we're very much looking forward to the partnership, which I think Mark just announced. And by the way, the ink is still wet on it, but it is signed. And I'll get into some explanation of our vision with PAS and with operators. Now, let's see if I can do this. Great. First, to give a little context, I just want to describe the Alstom Group. We are about a $25 billion company worldwide, 93,000 employees, and as you can see, we're heavily embedded in major infrastructure industries. We develop technology and we deploy technology. Today I'll be talking mainly about the power generation space, where we run everything from the low to no carbon options being renewable and nuclear, to the very reliable and much needed fossil options, where our focus is on high efficiency and increased flexibility, and for the potential future need for carbon capture and storage. For grid, you'll see a couple of descriptions there. We work on basically both the hardware side of the house and the software side of the house. Hardware, the focus is, you may already be aware that there is a lot of wind generation at remote sources across our country that needs to be moved efficiently to load basis. We are active in developing and deploying HVDC technology for that purpose, as well as some flexible AC transmission technologies to maintain power quality, power stability, especially in light of all of the changes, the renewable integration, the change in operation that we're seeing both in generation and in transmission. And I'll mention transport. I want to make it clear we're on the passenger rail side. So again, another big project type of industry, metros, light rail vehicle. Chances are you've ridden in one of our cars. I bring it up because HMI has its role there as well. Harvey just spoke about the fact that he'd like to be able to swivel a chair from one screen to another, one control system to the other, and see the same interface. Well, the transit systems have the dream also of being able to take operators from train to train to train without missing a beat. HMI is critical there. I'll skip all of that. I think this is my last comment on Alstom. I mentioned 93,000 employees worldwide. We are over 7,000 strong here in the US. 50% of the power plants, even some of Harvey's power plants, have some form of Alstom equipment. And 40% of the power that flows through the wires is managed by our software. So we are very present in the US market. All those dots that you see there, those are the installed power generation base that has our technology across the fuel drivers. Point here, we are embedded in the US market. We are perfectly engaged on a daily basis with the power plants, with the operators. And I want to say a little bit about our vision, mainly that we're focused on growth, obviously, technology, as well as operational excellence. When you look at the growth piece, we go to the customer and we say, how do we grow? And they're telling us right now, expand your service activities, expand geographically, and more than anything, improve your product portfolio. So when we look at the technology that we're developing to this end, we've noticed an important change through the years, and that is that the integration of advanced software, advanced information intelligence, the integration of that into our products to make smart products has become nearly as important as performance and reliability. It is a switch, and we're taking it very seriously. So now I want to get to how we found PAS, and it's been a process. As you can imagine, we have thousands of R&D engineers, and they are constantly innovating new products as well as upgrades to the existing base. So there's no doubt, in my mind, they are the best R&D engineers in the world for gas turbines, for boilers, for steam turbines, for plant integration. But we thought that we'd try something different and actually give them some direction for their innovation. And we thought to do that, we would harness the industry and get the voice of industry. But of course, being an engineering company, the way you have to do it is to make sure that it's statistically significant. Otherwise, no one will believe you. So we wanted to touch 17 countries across the world and a variety of plant types with these conversations. And in order to do that and have each of those 17 set of data from across the world have statistical significance, we calculated it would take 510 conversations. But we knew we had to do that, otherwise the engineers would tell us, we don't believe you. So instead of 510, we had 654 conversations. And operators were a huge piece of that discussion. And we heard things that were expected. I mean, after all, what we were looking for is what are the must-haves? What are our products and services that have to have? Even looking for those areas where those are nice to have, but not terribly valued, so we're overselling a bit there. But most importantly, we were looking for those critical needs, important needs, that the industry has yet to meet. And I mean industry, not just Alstom. So one of those areas was improved operational reliability, which may sound funny to Harvey because gas turbines typically on a year-round basis have anywhere from 93 to 96% reliability, which is pretty admirable. But there is absolute belief that there is still a gap there and room for improvement. So when we take that to our engineers, they think, okay, reliability, okay, materials, coatings, firing temperatures, rotor design. But what we heard in the interviews was quite a different interpretation of reliability, and I'll show you some of the quotes. And these are the direct quotes, just a sampling of them that we got from the operators that we spoke with. And it was a bit of a discovery for us because these really don't have anything to do with our materials, our firing temperatures, etc. They have everything to do with the human element and the human interface and the way that information is presented. So we went through all of the data points, all of the quotes. We organized them into these 4 categories: the human factor, root cause analysis, trip prediction and protection, as well as tuning and calibration. And we have teams of engineers who are now believers, by the way, ready to attack these topics, and they have already. They've taken it to the next level so that they can incorporate it into what they're doing. And this strategic initiative we're calling Simple to Operate. So here's a vision. It looks a lot like what Harvey showed. So at least our vision is correct, I think, if one of our customers is saying, yes, this is what we want. When I first started talking to our gentlemen who were dealing with PAS, they kept talking about, oh, it's about ergonomics. It's about ergonomics. And I kept thinking, when I hear ergonomics, I think carpal tunnel syndrome. And I'm thinking, I'm sure that's not what we're after here to save the wrists of the operators. So we're looking at it a bit differently, and we've coined the term cognitive ergonomics. making sure you have the right information at the right place at the right time. And it is really just that simple, and that is what we're hearing from the customers. And Harvey did great justice in showing you how to whittle that down. The other thing that we heard is in this brand new vision that we have, please make sure, the operators told us, that there is some level of customizability, which may sound counter to what we're trying to do. However, power plants are all different. As much as we standardize and modularize, the reality is every site is different and has a different set of inputs, a different set of, for instance, state by state and slightly different emission requirements. So we will have the ability, and with every installation, we will sit down with the customer with some training from PAS and adapt to project-specific requirements. Okay, so what is this group who's working on this strategic initiative doing? We've broken it down into 4 work packages, and 2 are directly related to PAS, and who knows, maybe in time all 4 will be. But I'll start with the work package called User Interface. What I haven't explained to you sufficiently is that there are major transformations going on in the power industry. Harvey can tell you about it. It's change that we've never seen before, quite frankly, in the history of the industry. The first one is, as I mentioned, the integration of not only renewable sources, which tend to be intermittent in nature, the sun, the wind, but also a lot of distributed resources, which means, for instance, when we take a look at the combined cycle plants that were ordered in bulk some 15 years ago. When we sat down with the people running the pro formas for those investments, the Southern companies, the developers, it was clear their intention for operating these combined cycle units was what we call base load. So let's say running the machine 75 to 95% of the time. That has not happened. First reason is because of the volatility of gas prices in the beginning, which no one predicted. The second is because of the renewable portfolio standards, because of the need to respond to other sources that need to come in. These plants are now starting and stopping, sometimes on a daily basis, running in low load operation, part load operation, cycling. There's a lot of movement. It was never the intention. So that's the first big change. The second is, and I heard Mark talk about it, the onset of big data. As our technology capabilities improve, so does our ability to gather and deliver more information, big data. But it is, and that will continue to happen, by the way, but the big data is no good unless it's the right data at the right time. There has to be some filtering and organization. I'll draw an analogy here to what we did on the transmission side of the business, the grid side of the business. We acquired a company, I think 2 years ago now, that had what are called PMUs, so phasor measurement units. And it basically gives us the ability, the RTO, the ability, the distribution control room, the ability to collect data about 100 times faster than just, say, 5 years ago, which is great. But we had to take it a step further on the distribution side, get into the control rooms, for instance, at Alabama Power, and figure out how to transform this information. It's great that it's coming earlier and it's coming faster. How do we transform it visually? Because what the dispatchers told us are, look, all we want to know is where is the fault? We want to get that information early so we can prevent any cascading. And we would like automated restoration where possible so we're not spending our time or an undue amount of time scheduling dispatch crews. So the user interface, these are the areas that we want to address. We need to bring this to the generation side of the house. Alarm management, I'll go into that into some detail, but I would say it's not just about alarm management, it's actually about instructions, some root cause analysis, some troubleshooting. On the operator automation area, this focuses mainly on abnormal operation, I'll call it. For instance, a startup. How can we get to the point where it is push button? And we hear the term all the time in the industry. It's push button. It isn't really push button. And that's where we need to focus. Not only that, but auto-tuning, for instance. There are so many parameters that run in balance, knocks, pulsations. How can we get to a point where we're auto-tuning them within that balance, within a band? And then finally, asset management. The lifetime of this asset is everything to the owner of this asset. So we're intent on bringing real-time condition assessment, real-time consumed life, and going a step further and giving the operator some options, some economic trade-offs. For instance, a trade-off between maximizing output because the situation is right in the market, or choosing to go for life extension or life preservation. We want to bring those options directly to the operator in very simple visual format. Oh, I'm going backwards now, sorry about that. So I'll just say a few words about alarm management. Again, in the study that we conducted, the operators, more than one, and it wasn't just about our machine, by the way, told us that alarms go off all day long. And they've gotten to understand the pattern of these alarms. And not only do the alarms go off, but then is produced sheets of paper that have at least 200 lines of data. Not in any particular order, not in any particular sequence, and far from instructional. They've gotten to the point where they actually ignore these alarms. And so we want to do just the opposite. We want to get rid of what I would call nuisance alarms so that the operator can take the decision that he or she needs to make as quickly as possible. The last thing I'll point out about alarm management, you'll see the numbers, 144, 1,200, 1,500, 2,000, 900. Well, for our industry, the power industry, it's estimated that at a plant, about 2,000 alarms go off in a day. I don't even know how you can make sense of that. And I'll be the first to admit that we don't know what the benchmark should be. That's part of the work that we want to do directly with operators and with PAS to determine what's the benchmark. Is it less than 10 alarms per hour? We want to get there. We want to simplify this. And the user interface. Engineers, I can speak to that because I am one and I work with them all day long. Engineers like to give information in the way that engineers think, I'll say. So in the form of spreadsheets or rows of data. But the fact of the matter is operators are changing, generations are changing. I just look at my children and how they spend their time at some form of interface. And the fact of the matter is the video game culture has collided with our traditional engineering practices. And we want to take an opportunity for this collision. We want to make sure we're incorporating it into our new designs as well as retrofits to the install base. So I want to get back to the partnership here and how I would say that this is a very constructive layering. We've heard now from Harvey that the operators, they have incredible operator experience. They also have incredible desires for how they receive the information. You've heard now that Alstom has been around for quite a while. We have process knowledge. We actually have a lot of controls knowledge within our given field. And we have been in the field diagnosing our technology in their full systems for years. So we can bring that knowledge to what the operator needs and to what PAS is capable of producing. And in PAS, we have found, among many things, a proven product. I mean, you just heard it from Harvey. But there is another reason that we are very keen on doing this partnership. And that is that the 100-year history I talk about with Alstom, a lot of that came about through acquisition of technology leaders in the field around the world. For instance, some of you may remember the name combustion engineering, which was our boiler technology, which is where I grew up in the company, by the way. Not with combustion, it was ABB by then. It eventually was acquired by Alstom. Flack on the environmental side, acquired by Alstom. So we've come at it through a lot of acquisitions which bring individual identities into the company, and therefore we have a lot of unique solutions. We have a lot of idiosyncrasies, and we're looking to the power graphics as helping bring to us a measure of control to that end. If we can bring consistency to the human-machine interface, it will help not only the operators, but it will help us a great deal as well. So where do we see this partnership going? I know now we're talking about what we call thermal power, which is coal and which is gas, and where there's an extensive fleet and a lot of new generation going on around the world. But you can see our portfolio there. We have something that we call a balanced portfolio because not everyone in the world is blessed with the same resources. And the cost of electricity is different based on where you sit in the world for different fuel power generation technologies. So we'd like to test the waters and see, okay, if this works for coal and gas, which is our focus, can we apply it to hydro and wind and the others? So there's a lot we think we can do with it, again, with our new designs, new technologies, as well as with the existing installed base. We look forward to the productivity that we believe that this partnership, working also with our customers, can bring to the industry, and the improved reliability as well. So we have just signed the agreement, and so now it's time for us to get to work. And so thank you very much.